Hi. In this lesson, we're going to be working with an introduction to functions. Now, before we get started, we first have to ask ourselves, what are some definitions that we want to work on? What are some definitions that we need to know? Well, to be fair, this chapter is going to have a lot of vocab words that are going to be introduced to us for the first time. So in every lesson, we're going to have a set of words that are going to be our vocab words that we should always remember and write down. So in this lesson, we have a set of four. The first one is called a relation. A relation is a relationship between every input and output. In other words, an X and a Y. Think of a coordinate pair, which you're used to already. A coordinate pair happens to have an X and it happens to have a Y. Well, every coordinate pair, that X and Y is a relationship with one another because it creates a point. That's called a relation. Now, a function is taking a look at all these coordinate pairs and asking it, hey, can this work? Is it functional? Well, it's only functional if the x's do not repeat, which is why I want you to underline x's cannot repeat in order for it to be a function. We're going to go over this later on in the lesson. The third vocab word is going to be domain. Domain is for every single input, other known as the x. So I want you always to memorize that domain will always represent x. And then the last one is range. Range will always represent the y, the output. Okay, so domain is x, range is y. Relation is the relationship between the x and the y that make a coordinate pair. And in all these coordinate pairs, if it's a function, it's going to be functional if the x's do not repeat. Those are for vocab words. So let's take a look at all the different ways that we can write a set. All the different ways we can write a relation. The first way we can write a relation is as a set. A set, you'll notice these brackets on the side. These brackets will help represent what's in there. Now, normally, every time you write a set, which I'm going to go over in a few slides as well, you want to write it in order if you're able to, and you don't want to repeat them. Next, mapping. Now, mapping is interesting because if you notice, it doesn't really have the numbers next to each other. So if you take a look at the last slide, it was 2, 6 next to each other. But in mapping, you have to actually work for it. You have to first ask yourself, 2 goes with what number? Follow the arrow, 2 goes with 6. So what I always tell my students is, if you see mapping, write them out as coordinates, write them out as a set. So the first one's going to be 2, 6. The next one's going to be 5, -1. And the last one's going to be written as 6, 3. Now, to me, it helps me out a little bit more when I write it as a set compared to mapping. Third method is something that you're used to. It's table. Now, table's kind of self-explanatory. They're next to each other. The x and the y, that relationship that you're looking for, that coordinate pair, is written next to each other. So, for example, this is 2, 6 and 2, 6. I know these go together because they're written next to each other. Now, our last method is going to be graphing. Now, when it comes to graphing, you have to always remember a graph is graphing a coordinate. Now, I know you're familiar with coordinates from back in the previous lesson, the previous years, but a coordinate has an x and a y. Every x and a y is called a relation. You have to always remember this is the x coordinate and this is the y coordinate. In case it helps you out, the way I list the y coordinate is draw a line from the stem of the y, and that lets you know you have to go up and down. So when we're graphing 2, -6, you're going to go 2 on the x, 1, 2, and then you're going to go 6 units down. And that's how you get your point, 2, -6, and that's graphing. Now, this is the part where it gets interesting. They're going to ask you how to describe domain and range. You're going to be able to describe domain and range as a set or something called set builder notation. But you write it as a set, which is a collection of things, if and only if it's a table, a set, or a mapping type of question. If it's usually a graph, it's going to correspond to set builder notation, which is defined by the set that you see below it. Now, in a set, I want you to always remember if there's nothing in the set, that's called an empty set. There's nothing in there, so it's empty. And then if your set has, like for example, 1, 2, 3, that represents 3 items in that set. Remember, every set has to be in numerical order, least to greatest, as well as do not repeat the numbers. Now, when it comes to set builder notation, unfortunately, this has a little bit more that you have to remember. This x can be interchanged with any letter that you're working with. So domain is x, range is y, and this bar represents the word such that. So when you read this set, it says x such that, and the last part, this part right here, this is just your answer. Whatever your answer is going to be, you're going to put it in there, except notice it's an inequality. And that's something that we're going to work with because on a graph, sometimes it has a starting point and a stopping point, and vice versa, which I'm going to go over next slide. But that's a part of your answer. So when you read it again, it says a set, x such that, whatever your answer may be. And then the last thing is, what about your inequalities? Well, if you remember in chapter 2, sometimes you can have an open circle or a closed circle. An open circle corresponds to less than or greater than, and a closed circle represents a less than, greater than, or equal to. Okay, that equal to plays a major role in closing your dot. So on the next slide, it's going to ask, how do we write set builder notation? Now, to be fair, in my opinion, I think we need to practice a few and then come back to this. But what I want you to remember is set builder notation is whenever you're graphing. It's going to start off with X such that or Y such that, depending if you're doing domain and range. Now, what I want you to remember, every time, look at all the arrows that you see in your problem. All the arrows face it the same way. They face the left. They're all less than symbols. That's something that's going to be a constant within your problem. Now, the one thing you want to remember is this is your starting point and this is your ending point. So if you have a starting and ending point, you're going to write it as the top equation. If you don't have a starting or ending point, that means that your graph technically has an arrow on both sides. Now, when you have an arrow on both sides, it technically goes on and on. So that means that your domain or your range is going to be the set of all real numbers, which is defined by this symbol right here. We're going to write it as two stems for the R and then write it like that. That represents the set of all real numbers or all real numbers, okay? And then the next one is going to be, what happens if you have a starting point and no stopping point? Well, notice a few things. If you have a starting point and no stopping point, what that means is I have a starting point, so I care about my starting point, which is right here, but I don't have a stopping point, so I'm going to ignore this. Well, if I ignore that, that means I'm not writing the second half, which means I'm only left with the first half, and that's exactly what you see right here. So a starting point means there's a real point there and then no ending. Now, vice versa. What happens if you have no starting point and an ending point? Again, you have no starting point, but you do have an ending point. What's going to happen is you have no starting, so you're going to cross out the beginning, and you're only left with the ending, which looks like this, and that's exactly what you see on the last one. You want to be very careful with these, okay? This is not easy, but it's one of those I want to introduce it so that when we go over a graph domain and range, you'll be more aware of it. So now moving on to the next slide. We can finally try our first problem. It's going to say this: find domain and range of the given relation. So we have to ask ourselves, wait, what's domain? Domain is always going to be the X and range is always going to be the Y. So when we have to ask ourselves what is domain and range, for domain, you're going to look at all the X's. 2, 5, 6. And then what we're going to do is we're going to list them. So how do we list them? Well, we write it as a set. So I'm going to call it D for domain. And then I'm going to write it as a set. Be careful with the brackets. And I'm going to put it from least to greatest. So in this case, it's already written from least to greatest. So it's going to be 2, 5, and 6. And I'm going to close the bracket, and that's my answer. I'm then going to move on to range. What's range again? What letter? Range is my Y. So I'm going to look at every single Y coordinate or Y part of the coordinate. Now I'm going to write it in order from least to greatest. So it's going to be bracket, -1, 3, and 6. And that's how I write my domain and range. But they're not going to always be written as a set. Sometimes it may be written as a map. And if it's written as a map, well, then I have to ask myself, well, what do I do if it's written as a map? Well, the first thing that I'm going to do is I'm going to first rewrite every single coordinate point that you have as a point. So what am I going to do? I'm going to write it as a coordinate. So what is this? I have to ask myself, what does the number -3 go with? What does it go with? It goes with 13. So I'm going to write it as -3, 13. And then afterwards, I'm going to go with 4, 1, 7, 6, followed by 8, 13. And that's my set. So now when they ask me for domain, I can do that. How do I do it again? Domain stands for D. Domain is all of the X's. So take a look at all the X's that you have that you're using on the coordinate points. It's -3, 4, 7, and 8. So it's going to be -3, 4, 7, and 8. And then follow it by doing the range. Same concept. Range is all the Y's. So that's 13, 1, 6, and 13. I'm sorry, one mistake. This is not supposed to be 13. This one is supposed to be, what number is it? Hopefully you caught it. It's supposed to be just 6, right? Because 8 goes with 6. Luckily, I caught that. So when I do my range, these are going to be the numbers. It's going to be 1, but notice 6 appears twice. Do I put it twice? No, I put it 1 time. And then my last number is going to be 13. I'm going to close it, and that's it. So again, my mistake for having 8 go with 13, 8 actually went with 6. Luckily, we caught that. But when we list domain and range, domain are x's, range are y's. Do not repeat the numbers and make sure you go from least to greatest. Now, for example 2, ask us what they're asking us. They're asking us to find a domain and range. So because of that, what does domain represent? Domain represents the x and range represents the y. When we're doing example A, if you feel comfortable, try it on your own. Once you're ready, press play and I'll be here to answer it. So I'm going to go ahead and try it. It says find domain and range. Domain is x, range is y. So when I'm asking myself what the domain is, I'm going to list all the x coordinates. And I notice that 4 repeats, right? So because of that, what I'm going to have to do is I'm going to have to list them from least to greatest, but I'm going to have to not repeat the numbers. So my answer is going to be -1, 2, 4, and then close brackets. Now, when I do range, it's going to be the same concept. What are all the y's? So I'm going to double underline it so that we see all the ranges. And luckily for me, nothing repeats, but they are out of order. So I am going to have to write them in order. So my range is going to be -1, 3, 4, and 7. That's my answer. That's my range. Now notice the table. We haven't worked with this, so I want you to notice something. You all notice this f of x right here? This f of x, which we're going to work with the next lesson, but I wanted to introduce it because it's so important in what functions are. F of x is 99% of the time known as y. So if you ever see f of x, write it as y because it's going to represent the same thing. It's just the name of the function. So what we're going to do now is we're going to ask ourselves, okay, well, what's domain and range? Well, luckily for me, a table breaks off all the x's and all the y's already. So the x's are all here, and the y's are all here. So because of that, when I'm asking myself what is the domain, I'm going to say domain is equal to, make sure they don't repeat, 2, 4, 6, 8. Close it off, and you're done. And then range is going to be the next column, which is going to be, is it -2, -6? Nope, because hopefully you caught yourself. It has to go from least to greatest. So it's going to be -14, -10, -6, and -2. Close it. Do a better bracket. That was terrible. And that's it. So as much as you may struggle writing these little brackets, so do we. Sometimes you try to go too fast, and unfortunately, it doesn't look the best. So don't let the brackets be the hardest part. So in this problem, remember, domain is x, range is y. Do not repeat the numbers and make sure you put them from least to greatest. Then we move on to a graph. Now, unfortunately, a graph is one of the hardest methods you could ever have. Why? Because you're going to have to write it in set building notation, which if you remember, it was x such that, etc. So here's what I'm going to do. This is what I always recommend my students. I want you to take a screenshot of only the graph. Everything that's not around the graph, ignore it. Or draw a box or a rectangle around your graph. So this is what I'm going to do. I always like to start off at the lowest point on the left-hand side, which is right here. And I'm going to draw a rectangle around my box. Around my graph, I'm sorry. So perfect that if I were to take a screenshot, I'm only going to focus on that small part. Now, we have to ask ourselves what the domain and the range are, right? So domain, we said is x's. I know we all know that. Domain is x's. But x's are what part of the graph? If you notice, x is right here. X is left to right, left to right. So when you're finding your domain in this, you're going to ask yourself, how far left do I go? That's my starting point. And how far right do I go? That's my stopping point. Where do I start and stop? From left to right, from left to right. So what we're going to do is you're going to go to the farmost left point of the graph, which is going to be right here. Now you're going to ask yourself, remember, we're doing domain. What x value is that point? Well, there's a point right there. So what point is that? What x is that? I hope you agree it's -2. So when I write this set, it's going to be x such that -2. Now remember, it's always a less than symbol. What the question is it going to be an equal to? Well, an equal to happens when it's a closed dot, which you agree that point is. It's going to be a closed dot. And then I'm going to put an x here, and I'm going to ask myself, same symbol. Do I stop somewhere? I do. Where do I stop? I stop right here. What's the x value? The x is right there. So what number do I stop at? I stop at 1. So because of that, my answer is going to be less than or equal to 1. Then I'm going to close circle. So take a look at it again. This beginning part is where I start, and this end part is where I stop. Remember, I'm doing x, so it goes left to right. I start at the -2, and I go all the way to 1, and that's my start and stop. And why are they both closed circles? Because that's how the graph was given, so therefore it's going to be an equal to symbol on my answer. So now the next part is going to be, what is my range? Well, remember, range is how low to how high. Why? Because it ranges the y, and that goes up and down. That goes vertical. So you're going to ask yourself, how low does your graph go? But answer it in terms of y. So I'm going to put y such that, what is the lowest y that you get? Would you agree it's right here, -1? So I'm going to put -1 less than equal to, because it's a closed circle, but I'm not going to put an x this time. I'm going to put a y. And then the last part is, how high does my graph go on the y? Remember, we're doing range. Range is how high. And I go up to what number? I go up to 4. And since it was a closed circle, it's going to be equal to as well. So remember, range is how low to how high, looking at only the y's. Domain is left to right on the x's. And that's my answer. So if you notice, that was kind of interesting. It wasn't as easy as listing them as in a set like x on y's. Now we have to actually think, where do I start? Where do I stop? But to be fair, if you draw a rectangle around your graph, it does help you out because it limits everything to what you're just focusing in. So now we're going to try example B. Now, if you feel ready off of example A, I would recommend you starting example B on your own and then pressing play when you feel like you're ready. But what I'm going to do is, I'm going to go ahead and solve it. Now, the first step that you want to ask yourself is, what should I do? Well, the first thing you do is you're going to draw a rectangle. So always start off on the left point, go up, over, down, back to the left. Now, if you do this, you have a perfect screenshot of your answer. So when you ask your domain, remember, domain is x's. X is left to right. So you have to ask yourself, how left do you go? Well, I don't have a coordinate here. So what I'm going to do first is I'm going to write it as a coordinate. This coordinate, I hope you guys agree with me, is -3, -4. And the one on top is 1, I'm sorry, it's not 1. It's 5, 1. So what I'm going to do for my domain is, how left do I go? What x value do I start at? I hope you have it. It's going to be x such that -3 less than or equal to, because it's a closed dot, I'm going to put the x because that repeats every time. Now, where do I stop? I started at -3 on the left. Now, where do I stop? What's my rightmost point? My right is right here, but what x value is that? 5. But the question is, it's an open circle, so because of that, it's not going to have the equal to. I'm going to close the circle, and I'm done. Okay? So now we're going to do the same thing for the range. Range is how low to how high. Again, it's going to be y such that. How low does your graph go? How low? It goes to the y value, which is -4. It's a closed circle, so it's going to be equal to as well. And then how high does your y go? It goes up to 1. And it's an open circle, so it's going to be a 1. And that's my answer. Again, how low do you go to high? But you're only looking at the y values for range. And for x is going to be domain. Okay. So now we're going to move on to the next question. Next question is going to be the same concept. You have a graph, but notice something. Now there's an arrow. Now remember the slide that we said that there was 4 different ways? Arrows mean there's no stopping point. It keeps on going. What does it mean it keeps on going? Notice your graph keeps on going up, but as it's going up, isn't it also going to the right? Same thing on the left-hand side. Well, when a graph keeps going up and up, that concept is called infinity, meaning it's going to go to infinity. It's not a concept that's usually taught in Algebra 1, but it helps you determine where that goes. Infinity is like a concept that means that it's never ending. It's going to go to some point that's unknown. It's a conceptual question. So when I answer this question, I'm going to still draw the rectangle because I still have to answer the domain and range. So what I'm going to do is I'm going to draw a rectangle around everything around my graph. Now I'm going to try to be as good as I possibly can be to draw that rectangle. Now what I'm going to ask you is this. When I'm asking myself, what does my domain represent? Do I actually have a starting point on the left-hand side? Now, starting points. Do I have a point on my left-hand side? Unfortunately, the most left I have is an arrow, which doesn't end. So I don't have a starting point. So I'm not going to put that because there's no actual point where my graph starts, because if my graph kept going up, I'm going to have to zoom out and it'll never be a point. But what about an ending point? Let's look at the right side. The right side also has an arrow. So I'm not starting and I'm not stopping because my graph keeps getting wider and wider and wider and wider. So what does that mean? That means this. My answer is going to be x such that, because I'm working with domain, and I'm going to put the set of all real numbers. Why is that? Because every single answer will be touched on the x-axis because my graph is going over to the left and to the right continuously. Okay? So again, when you don't have a starting point and you don't have a stopping point, that means it's going to be all real numbers. Now, also remember, I had you write down double arrows on opposite sides. You see how there's an arrow on the left and arrow on the right? That's because your graph's never going to stop. So now let's do the range. For the range, we're going to ask ourselves the same question. How low do I go? How high do I go? Well, range is the y, so I'm going to put y such that. Now, how low do I go? I go all the way to this point right here, which is what y value? Remember, y, if you said 2, you're looking at the x. Don't look at the x, look at the y. The y is 1. So we're going to have a starting point of 1. So I'm going to put the less than. This is going to be equal to, because it's a closed circle, y in the middle. Now, what's my ending point? Well, let's look at top. You have a point on top. You don't. You have arrows. What does that mean you have arrows? That means your graph keeps going up and up and up and up. So where do you end? Don't. If you thought all real numbers, remember, all real numbers is when there's an arrow on the left, the right, the bottom, on top. You have a double arrow. Yes, there's 2 arrows, but they're both going upwards. So because I have no ending point, I'm not going to write an ending point, which means I'm only going to have a beginning point, and I'm going to close my set. That's my answer. So again, when you have a double arrow on the left or the right, it's going to represent all real numbers. But if you have a starting point and no ending point, that means that when you write inequality, it's going to be only the beginning part and not the end, if you have a starting and not an ending. So go back to that slide that we went over to help you determine what's the starting, what's the ending. Now, if you feel like it doesn't make sense, don't worry about it. A lot of students struggle with this until we do more examples. So if you feel ready, try B. I'm going to start it as well. I'm going to draw a rectangle from the leftmost point. I notice there's an arrow and there's a closed dot. So when I ask myself, what does domain represent? Domain is X. How left do you go to how right do you go? So what am I going to do? I'm going to put X such that how left do I go? I notice that there's an actual point here. I'm only asking for domain. So what's the X? It's -3. So I'm going to put -3 less than equal to, because it's a closed dot. I'm going to put an X because it's domain. Now I'm going to go to the right point, but I notice there's an arrow. An arrow means there's no ending. So if there's no ending, I'm not going to put all real numbers because the left didn't have all real numbers. So I'm just simply going to close it. That's it. Now I'm going to move on to the range. I'm going to do the same concept. How low to how high? How low to how high? So for range, I'm going to go y such that my lowest point is an actual point, but I care about the y because I'm working with range. Range is the y. So my y is 2 less than or equal to y. Do I have an ending point? I don't. If I go all the way to the top, it's another arrow. Arrow means it keeps going up, so there's no ending point. So what am I going to do? I'm just going to close it. That's domain and range. So again, if you have a starting and ending point, you put 2 numbers. If you have a starting, you only put the beginning. If you have an ending, you only put the end. And if you have no starting and no ending because there's 2 arrows on opposite sides, then it represents all real numbers. Okay? So now for example 5. Now you're going to notice for example 5, 5a has a circle. But notice what you don't see about this problem. What isn't there? There aren't any points. So what do we do? How do we know how left and how right and how low and how high if we don't have points? Well, the good thing about a graph is you can create your own points. Even though they're not there, you can always just make a point there because that's the one that corresponds to it. I'm going to do one on the left. I'm going to do one all the way on the top and all the way on the bottom. Why? Because that's what domain and range are. Left, right, bottom, and high. So now that we have these points, remember, this coordinate is -4, 4. This one is 0, 0. This one is 4, 4. And the one all the way on the top is 8, I'm sorry, that's not 8. 0, 8. So what we're going to do is we're going to list these x's so it helps us out when we're going left to right, down to top. So first, I'm going to draw my rectangle, or in this case, it's going to be a box because it's a circle. Doesn't have to be perfect. Just draw the best one you possibly can. And we're going to ask ourselves for the domain, how left do I go? What's the leftmost point? It's right here. What's the x of that point? It's -4. So I'm going to put x such that -4 less than or equal to. Wait, how do you know if it's open? Guess what? If it's open, they're going to tell you it's open from the very beginning. Okay? So -4 such that, -4 less than or equal to. I'm going to put the x. And then now where are we ending? We're ending at this point. It's not an arrow, it's a point, so it's real. I'm going to put less than or equal to because it's a closed circle. And then what's the x of that coordinate? 4. In this case, I get kind of lucky because they were both 4, 4. So I get lucky. But remember, domain is left to right on the x's. Now I'm going to move on to the range. Range is what letter again? Range is the y. So y such that how low do I go? I go down here, low for the y, and that's going to be 0. Closed circle, y in the middle. Closed circle, where do I end? What's the highest y I get to? It's 8. And that's my answer. 0 from the y to the 8 on the y. So now I'm going to try B. Remember, once you're ready, stop the video, pause it, try it, and see what we get. In this one, I'm going to draw my rectangle. I notice there's arrows. I'm not going to freak out. Arrows just mean they go on and on, which means I don't have to write anything. So now I'm going to ask myself, what's my domain? Now remember, domain is how left to how right. Go to the leftmost point. There's no point. There's an arrow. So that means that I don't put anything. So now I'm going to go to the right side. Right side, find the point. That's right here. There's an arrow. That means I don't write anything. Well, if I don't write anything on the left, I don't write anything on the right, what's my answer? My answer is all real numbers. So my domain is going to be x such that the fancy r. That's it. Let me write a better set. My apologies. There we go. That's better. Remember, don't let the set be the hardest part about this problem, okay? So again, domain is how left, how right, but if there's 2 arrows, all real numbers. Now let's do this one, the range. Range is how low to how high on the y. So y such that. How low do I go? There's an arrow, right? How low do I go? There's an arrow here and here. So my graph keeps going down, 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 where? To infinity, but not positive infinity. It's actually negative infinity because I'm going on the negative side. So infinity could have a positive negative. Remember, not an algebra 1 concept, but it means that's how far you go. So I don't stop. So because I don't stop, because I keep on going down, I don't have a starting point. So I can't put anything. Do I have a stopping point? I'm going to go all the way to the top, and I do stop. There's a point there. It's closed. So because of that, how do I write that? How do I write a no start, but I do have a stop? This is what you do. You don't put the beginning. You put the letter you're working with, the arrow, equal to because it's a closed circle, and you put the x or the y if we're dealing with range. Put the y. What's the y? 1. So I'm going to close it, and that's my answer. So I don't start anywhere, so there's no beginning piece, but I do end somewhere, and that's where I put 1. That's my answer. Okay? So now we take a look at our last 3 slides. On these slides, remember the part where we said we're going to skip functions till the end? Well, now we're here. So we're going to ask ourselves, how do you determine whether a relation is a function? But first, what's a relation again? A relation is a set of points, a relationship between an x and a y. A function, we wrote down what? The x's cannot repeat. So you're going to have 2 examples. You're going to have a relation given to you as a set, a set, a table, or a map. Well, what do you do when it's given like that? You're going to just take a look at all the x's and make sure that the x's do not repeat. So in the first example, take a look at all the x's. Take a look at all your domains. Think about it. What are they? They're 2, 5, and 6. Can I ask you something? Do they repeat? They don't. So because of that, this would be a function. Yes. Now we take a look at the next example. You have 2, 6, 2, -1, 6, 3. Take a look at all your x's, your domains. 2, 2, 6. What do you notice? The 2's repeat. So what does that mean? It means that this would not be a function. No. So whenever you're given coordinates, just take a look at the x's. If they repeat, it's a no. If they don't repeat, then it's a yes. It is a function. But what about if they give it to us as a graph? Well, luckily, we don't have to do set builder notation because they're not asking us for domain and range. They're asking us whether or not it's a function. So what are we going to do? This is called the vertical line test. What we're going to draw is a vertical line. Remember, a vertical line is a line that goes up and down. And what we're going to do is we're going to ask ourselves, how many times does that vertical line cross your graph? If it crosses 1 time, then it is a function. If it crosses multiple times, then it's not a function. So let's try it. You can draw your line anywhere, but to be fair, draw it in the most complicated, which is usually the middle. I'm going to draw a line up and down. How many times did that line cross it? It crossed 1 time. So because of that, this would be a function. Yes. Take a look at the circle. I'm going to draw a line anywhere. How many times did I cross it? I crossed up here and down here. So because it's crossed multiple times, my answer would be no. And that's it. So if it's given to you as points, make sure the x's don't repeat. If it's given to you as a graph, use a vertical line test to determine whether or not it's a function. If it crosses once, it's a yes. If it crosses multiple times, then it's a no. So in these last 2 slides, try them on your own, see which you can do it, and see what happens. So in example 6a, I'm only going to look at the x's. -1, 2, 4, and 4. Wait, what do you notice? The 4's repeat. So what does that mean? This answer would be no. Now, table is your best friend because the x's and y's are already broken up. Remember, f of x is y. So take a look at all of your x's. Do you notice anything? 2, 4, 6, 8. Do they repeat? They don't. So what's this answer going to be? This answer is going to be yes, it's a function. Now we move on to example 7. Now it's a graph. So what do we use? We use what type of test? A vertical line test. Where are we going to draw it? In the middle so we can get the most complicated part. I draw it down. How many points do I cross? I cross twice. So is this a function? No. Move on to part B. Draw your vertical line. How many times does it cross? 1 time. So what does it mean? It means that this would be a function. And that's it. So on our last slide, we're just going to kind of go over the stuff that we got to remember. A relation is a set of ordered pairs. It can be expressed as a table, a map, a set, a graph, however you want to see it. The next comes a function. What's a function? A function is whenever the x's don't repeat if it's a set of points, but if it happens to be a graph, you're going to make sure you use a vertical line test, and that's what a function is. Now afterwards, in the relation, you have to remember a relation is a set of x and a set of y. That's domain and range. Domain is the x, range is the y. If you remember that, you're going to be great. Okay? So I know this was a long lesson, but there was so much information that you need to know for the introduction of function. So thank you for watching and best of luck.